Hi there. I thought I'd tape a quick video today on the quiz that we took on Friday, February, I do believe that was 17th. So this is actually version 2, but all of the versions were very, very similar. So you do the problems kind of the same way. So if you look at number 1, this is a central angle. The center is, the vertex is at the center, so measure the angle is equal to the measure of the arc.
Mr. Duncan, Mr. Winsler, Mr. Dugan, and Ms. Fowler. Please
So in
report
this
to
case,
lab 1221, the green lab, for a meeting.
measure of the angle is equal to the measure of the arc, which is 104 degrees. So we have this problem. The answer is 104 degrees. Now the other ones may have different degrees, but you do it the exact same way. Number 2, it states that you need to assume that the lines that appear to be diameters are diameters, and I chose this one to be a diameter because it goes through the center, and it also included these two segments, so I add these two arcs together, and it set it equal to 180 degrees. So 10x plus 70 is equal to 180. Subtract 70 from both sides. 10x is equal to 110. Divide by 10. And so x is equal to 11. Number 3, it says find the measure of the arc or the angle indicated. This is an inscribed angle, and the vertex is on the circle. So the measure of the angle is equal to the arc divided by 2. So I actually need this arc right here, arc LM. I don't have arc LM, but I do have some information that I can use to find arc LM. So I know the whole entire circle is equal to 360, and I know that these two parts added together plus 82 is equal to 206. So to find the missing arc LM, I take 360 and subtract
Karen Bowe, if you're still in the buildings, please stop by the community school office.
So my
Karen Bowe.
answer is 154. So then I plug in 154 divided by 2, and I find that my angle measure is 77. Number 4, this one a lot of people had questions about because it talks about this angle measure being 84, and this is on the circle, so I would need that arc measure to go with that angle measure. So you can do it a couple of different ways that we talked about today. We do know this other angle measure, and we can find that by saying 180 minus 84. So that angle measure is 96 degrees there. And then we can use our formula. The measure of the angle is equal to the arc divided by 2. So 96 is equal to 3x minus 9 divided by 2. I multiply both sides by 2. I add 9. So it's 201 is equal to 3x. And so when I divide that out, x is equal to 67. Number 5, if you look at this one, the vertex of the angle is inside the circle. So I use the formula measure the angle is equal to sum divided by 2. So I add up my two arcs of my sum, so the arc of the angle that I'm talking about and the arc of its vertical angle, and divide it by 2, set it equal to 2x plus 18, and then I just simplify the left side, so it's equal to 200 divided by 2, which is 100, and then use my math algebra skills, and I solve for x is equal to 41. Number 6, we talked about today in class 2. We can find this a couple of different ways. We know that it's outside the circle, so the measure of the angle is equal to the arc difference divided by 2. So I can find this arc by subtracting it from 360. So in this case, that would be 210 degrees minus 150 degrees divided by 2. So measure of angle is equal to 60 divided by 2, 30 degrees. Now, we also proved that this has a special situation. It's called a circumscribed angle formed by two tangents, and the measure of the angle is equal to 180 minus the arc that it intercepts. And so in this case, it would be 180 minus 150, which would be 30. And we talked about that in class, and we'll talk a little bit more about that tomorrow. The next one is I have two chords that intersect inside the circle, so I multiply part times part is equal to part times part. And I use my algebra skills. 80x is equal to 72x plus 24. Subtract 72x from both sides. 8x is equal to 24, and x is equal to 3. Number 8, it's outside the circle, so it's it's outside times whole is equal to outside times whole. So 4 times 23 plus 4 is equal to 6 times 6 plus x. So I have 27 times 4 is 108, and that's equal to 36 plus 6x. Subtract 36 from both sides. It's 72. And so divide by 6, x is equal to 12. Moving on along, number 9, I want to find DE. So once I solve for x, I'm going to have to plug it in to find this measure. So this is actually a tangent. So I take my tangent squared is equal to my outside times my whole. Outside times my whole.
Mr. Blake, please report to the community school office.
So
Mr. Blake, please
144
report
is
to the
equal
community school
to
office.
8 times x plus 7. 144 is equal to 8x plus 56. 144 minus 56 is 88. Divide by 8. X is equal to 11. Moving on along here, these are two tangents, and from our formula sheet, I know that the two tangents are congruent to each other. So 3x minus 2 is equal to x plus 18 plus 2 minus x. 2x is equal to 20, and I divide both by 2, x is equal to 10. This next one, we know that a radius and a tangent form a right triangle. So I'm going to use the Pythagorean theorem. So 12 squared plus 9 squared, which is 81, is equal to c squared. Well, I don't really know what c, I want to find out what c is, but my answer is going to be this question mark, which is that small part. Well, I know from the center to the edge of the circle is the radius, and the radius in this case is 9. So after I solve this, plus 81 is equal to c squared, 225 is equal to c squared, square root of both sides, 15 is equal to c. I know the whole thing is equal to 15. And so to solve for the question mark, I take 15 minus 9, and my answer is 6. Number 12 is another one of our formulas, but we also can figure it out a different way. We know that this angle right here intercepts that at TFR. And so that's going to be 168 degrees because I multiply by 2. And then I know that this angle that I'm trying to find intercepts TSR. Okay? So we know that the whole thing is 360. So I can take 360 and subtract 168. And so at this point, I know that this arc over here is 192, and then I can divide it by 2 to find 96. Or from my formula sheet, I know that these two angles that are opposite each other in an inscribed quadrilateral are supplementary. They add up to be 180. Number 13 is another one of our formulas, but we'll just do it this way. So I know that this arc with the vertex of y, or angle with the vertex of y, is 62 degrees. And it intersects the circle arc JZ. So that arc would be 124 degrees because I just multiply my angle by 2. Now, if I'm talking about the angle that I'm looking for, it also intercepts the circle. The intercepted arc is JZ. So I know that that intercepted arc measures 124, and I divide it by 2, so it's 62 degrees. The last three kind of go together, and they were the same for all three, they just were mixed up. It says, which of the following describes ABD? And ABD is described most specifically by oops, I'm sorry, not major arc, but semicircle, because it is exactly 180 degrees. Number 15 asks for the inscribed angle, and the definition of an inscribed angle is inside the circle with the vertex on the circle. So it ends up being BAD. And then which of the following is described by AB? And notice it is a line, and it's a secant because a chord is a line segment. So that kind of goes through the quiz, and hopefully that will help you. And please come in for extra help if you need it. Thank you.